Lines of symmetry inside a shape. Discover. Max says, I can find two ways to fold this square in half. Question 1a says, is Max correct? Has he found all the ways of folding the square in half? And question 1b says, how many lines of symmetry are there in an equilateral triangle? Remember that line of symmetry is like a mirror line. It means both things are the same on each side. So it's kind of like having a mirror down in the middle. So let's share some of our answers. Now, question 1a, it says Max is incorrect. There are 4 lines of symmetry inside a square. So there are 4 ways of folding the square. So remember that line of symmetry means it's the same on both sides, like a mirror. So if you look at this line of symmetry here going horizontally, if we folded the paper over that line, it would look like this. We get this nice fold and there'd be no bits of paper sticking out around the edges. The next line of symmetry is this vertical line of symmetry. And if we folded this across, we'd end up with a piece of paper that looked like this. Again, nothing sticking out, no bits sticking out the sides. And then we've got the 2 diagonal lines of symmetry. And those diagonal lines, if we folded the square over, would leave us with these right-angled triangles. Question 1b. In an equilateral triangle, there are 3 lines of symmetry. And you can see that there. We've got 1 going vertical. And if we fold that over, we end with this shape. We've got 2 diagonal lines of symmetry. Okay, and then if we fold them over, we end up with right-angled triangles just like this. In an equilateral triangle, there are 3 lines of symmetry, but what about these triangles here? Well, this is an isosceles triangle. It's got 2 sides the same length and 1 side longer. Is that a line of symmetry? No, it isn't. If we fold that across, you can see this side looks very different from this side. So if we folded that piece of paper over, we would end up with it sticking out here, and you would be able to see this bit of the paper sticking out at the back. If we did another folding line there, and we folded it over, it would be the same thing. You can see the triangle on this side of the fold looks very different from the triangle on this side of the fold. So those are not lines of symmetry. Here we've got another isosceles triangle. And if I put a folding line here, yeah, you can see it looks completely different on both sides, the triangle does. We've gone from a corner to halfway along the other side, and that is not a line of symmetry. It's the same if we go from the other corner. We've created another folding line with 2 different looking triangles on each side. So if we folded it over, okay, we wouldn't get that nice, neat fold like we did up here. So no, they're not lines of symmetry. And finally, we've got a scalene triangle, all different sizes. Okay, the sides are all different sizes and all the angles are different sizes as well. So no matter where we put lines here, if we go from the corners to the middle of the opposite side, that is not going to give us any lines of symmetry. However, if we look at the isosceles triangles again, if we went from this corner to halfway, you can see both sides now are the same size and they look the same. And if we folded them over, we would get a nice, neat fold, just like that. And if we put a mirror along that line, this is what the reflection would look like. It would look like a complete triangle. And it's the same for this isosceles triangle as well. If we went down the center this way, you can see that both sides of the triangle on each side do look exactly the same. So an isosceles triangle does have 1 line of symmetry. A scalene triangle has no lines of symmetry. And as we saw here, an equilateral triangle has 3 lines of symmetry. think together. Dominic says he has found a line of symmetry in this rectangle. Is he correct? Explain your reasoning. So, is that a line of symmetry, a mirror line? If we fold this piece of paper, will it fold neatly? Question 2, how many lines of symmetry do the two hexagons have? Question 1, Dominic says that this is a line of symmetry. Well, even though these triangles do look the same on both sides of the rectangle, actually if we folded this over, it would look like that. Okay, it is not a line of symmetry. We would not get a neat fold. And if we put a mirror on this side of the line and looked at this, this is what the reflection would look like. So we would end up with this kite. The kite has two lines next to each other, the same length, and two lines next to each other, the same length. We call that adjacent angles. Now, does a rectangle have any lines of symmetry? Well, if we put a line vertically down the middle, you can see both sides are the same. So that is a line of symmetry. And if we did a line horizontally, you can see, yes, those are the same on both sides. So a rectangle does actually have two lines of symmetry. Question 2, how many lines of symmetry do the two hexagons have? Well, let's have a look at A. You can see this is an irregular hexagon. It's got different length sides and different size angles. We've got a big angle here, and then we've got 90-degree angles here, or right angles here. So if I put a line down there, you can see that's definitely not a line of symmetry. This part looks much different from this part. If I did a line of symmetry going that way, both sides look very different. And if I did a line across here, you can see, yeah, they're not lines of symmetry. But what about a regular hexagon? Well, if I did a horizontal line here, yeah, they look the same on both sides. That's the line of symmetry. If I went from this corner to this corner, yes, you can see this side looks the same as this side. If I went from the other corner to that corner, yeah, this is the same as this. That's 3 lines of symmetry. Are there any more lines of symmetry? What about if I put a line here? If I look at this side, is it the same as this side? Yes, it is. That is a line of symmetry. And if I folded the hexagon over, it would fold very neatly together. Here's another line of symmetry. Okay, exactly the same as the other one. We could fold this over and create a nice, neat fold at the top. And there's one more there. So a hexagon has 1, 2, 3, 4, 5, 6. It has 6 lines of symmetry. And if you've finished all the work in your book, have a go at the challenge question. And as always, answers at the end of the video.